data last week, some surveys, experiments, ways to get data. This week we spent some time talking about describing the data that we get from those. And we're going to break it into two parts, describing the categorical data, which is the main focus today. And Wednesday and Friday we'll talk more about describing numerical measures, using things like average, median, standard deviation, and the like. So in that, there's a couple, a distinction that's usually made, or useful to make, about between quantitative variables and qualitative ones. Sometimes the quantitative ones are called numerical. These measure, are types of variables that measure the numerical outcome. And for these type of variables, it makes sense to do things like add them up, or take differences between two values, or take averages. Makes sense to average, or subtract, take differences between two values, or maybe to scale them, to change to another quantitative measurement system, like going from Fahrenheit to Celsius, or other conversions like that. Key examples of variables like this might be dollars, weight, length, volume, some like chemical concentrations. It could be different force, right? There can be different scientific units of measurement on these things, right? You can do the average force, or the total force applied from different sources, right? You can also have counts of things, like the number of chickens on a farm, or the number of pigs, and so on. And so it makes sense to multiply those by whatever price you're going to get for them to get a kind of a total revenue, and things like that. The qualitative or categorical ones, in contrast, they record a group membership, or a category, or some type of level that's not necessarily strictly numerical. Right? You go to the doctor's office, they have a picture about pain scores. They have one picture that's supposed to be a 0, that is, no pain, up to 10. A picture of a face that's screaming in agony and is absolutely the worst pain imaginable. Well, from 0 to 1 to 2 are different faces, right? But it doesn't necessarily mean that a pain score of 2 is twice as bad as 1, and 4 isn't twice as bad as 2, and stuff like that. They're just kind of on kind of a relative scale. It's not kind of an absolute scale where you really want to average those things. But it records membership and so on, things like this, right? And so when in any one problem that you're studying, whether it's people or field biology or any other application, often you'll have potentially dozens of different ways of recording information. Some will be numerical, some will be categorical, and there's choices, and sometimes they relate to one another, right? So let's think about a few different things, right? So if you're recording your grades, right, what would be a categorical or qualitative way of recording grades?
Percent.
There's percents, right? So if you get kind of a percent score, right, that's more of the quantitative, right, or numerical. Because if somebody has 60% of the points and somebody has 80% of the points, that 20% of the points is a certain number, and that makes sense, right? Or so if you have like 5 exams or 5 homeworks, and they're kind of equally weighted, and you get different percentages, you could take average of those, right? And it's an average of those points, right? So I think score would be more quantitative, right? What would be more categories that we think typically get reported? Yeah.
letter grades.
Letter grades. So, you know, you can do A, B, C, D, and F, like some letter grades, right? Now, they do correspond to score and cutoffs, right? But you know, you might be tempted in GPAs kind of take a value for this and a value for that and average them together, but it's not necessarily so strict. This is more the categories, and the actual numerical scores are one of the kind of underlying thing that might be related to that. And you can have cutoffs, right? But depending on, you know, you might have a different grading scale, and then A's don't necessarily have the same percentile range, and so what an A and a B and a C mean in different courses, you know, could be a little bit, you know, not so fixed. The difference between 20% and 25% is always 5%, but the differences between these can be a little bit different. Right? But they can be related, right? So let's say, you know, say we wanted to measure sound, right? Say the sound volume, right? You could measure sound volume in terms of noise pollution. You know, how much noise pollution is there someplace? If you have a car or machinery, you know, how much noise does it make? If you're dealing with music, of course, there's a volume level that's going on. Sound is actually very important in the debate in Vermont over the placement of the F-15 fighter planes, right? Is that the bigger planes will make a lot more noise, and so how much noise will they make? Will they disturb some schools and different neighborhoods? And is the decibel, you know, is the volume level going to be beyond a safe level? So it's kind of an important thing to be measuring, right? Sound can be measured more in terms of qualitative. Or more of the quantitative side. If you want to measure sound in a qualitative sense, right? What do you have to do? What? Familiar with that, right? So decibels, right, is the measurement of sound, right? So if you had a machine that could actually measure the sound, you get a numerical value, right? And so the difference between 100 decibels and 120 decibels is a fixed amount, and it means a certain amount of sound, and it's, you know, that's constant. If you have 10 different planes and you're measuring their decibels that they produce as they fly past a certain point, you get the average of those, or the difference between two different types of planes, right? And that's a measurable, meaningful difference. Qualitative, right? What type of scale would you want to do for more of a qualitative scale of describing sound? You often describe sounds using some words, right? Loud, right? You know, it could be loud, you know, medium, right? Or more soft, right? If you had the decibels, you might set up boundaries, saying this is loud, very loud, or something like that. But you might ask people their response, right? Do you think this is a loud sound, right? And different people will have different opinions, you know. If you've got a coffee machine working in a library that's chunking along, and some people will say that's a loud sound, and other people say, no, that's soft, it doesn't bother me, right? So there could be a correspondence between this, where the cutoffs, or it could be, you know, just the categories. Loud isn't going to be loud all the same all the time, depending on how it's recorded. So you wouldn't want to say it's kind of give this a 3-2-1 score and say take an average and say it'd be better to say what percent of the time is it loud, what percent of the time is it medium, and like that, right? Other things don't have this clear connection to underlying numerical scales. So if you ask agreement with the question, you can ask, should St. Michael's have canceled the morning classes, or should they have had those and students are on campus anyway? Right? So was it necessary to do that? You could say strongly agree, neutral, disagree, strongly disagree. Could be a response that people give. And yeah, that's not really on a numerical scale. Different people interpret those things differently, but it's still a meaningful value when you ask, what percent of the students strongly agree that they should have canceled classes because of the snow? What percent were disagreeing or strongly disagreeing? You could summarize those numbers if they were going to do a survey and ask you what your opinions were about that. Right? There's any number of other things that get to now. In any type of question, whether it's numerical or not, you could have one or more other values, right? That sometimes you don't know. Some people might not say that they don't know what their opinion of that is, or they don't know an opinion about some other political topic or something. Some people will refuse to answer, or just might be missing for some reason, right? So if you're trying to record the decibel levels of planes, and it happens that as the plane's coming in, a fire truck is going by making a lot of noise. It kind of screws up the sound measurement, right? So if you do that, you might judge it as, well, we really don't know what the standalone sound of that was because of this outside interference, right? Or in a survey, people just skip some questions and get tired of answering, and or maybe just inadvertently miss a question that they're going to do, and it's missing. So those things can be there whether it's quantitative or not, and usually the surveys allow some type of recording of these things. Or after you get the surveys or the data, there's a possibility that the measurements won't be done correctly, or there'll be something that's just skipped. So they're missing, right? Beyond those, there are a number of ways to divide up human populations, right, with qualitative variables, right? So gender, for instance, usually record as female or male, right? In some studies that would be asking about different aspects of gender, they might include other categories or a more nuanced response, if that's the topic. But usually for other things, female, male is still the standard, right? But things do change over time in terms of the and topic, depending on who's asking and what they're trying to find out. Right? What would be some other qualitative categorical variables that would be used for describing people? Yes?
Race.
Yeah, race and ethnicity. And that's been asked in different ways over time. The current government standards are to allow people to give their own response, don't assume anything for them, allow them to give multiple responses, and so it can be very nuanced and produce data that's a little more harder to use, but it is still more representative of that. And that is, along studies done, the 1950s, and earlier, it just did not gather information that same way. And the conclusions and subgroups that could be studied was much more limited. Race, ethnicity. How about genetics? Where you could have presence or absence of some mutation, right, or some genetic allele. Yes?
Blood type.
Blood type, yeah. So blood type is a good category. And, so A, B, right? A, B, and O. There's also Rh positive and negative factors that could put in there. So you could record that separately or as different variables, right? In genetics, a variable that is, yes or no is also called binary. Two outcomes. Sometimes it's dichotomous is another word for that. There's a dichotomy between yes and no. Female, male is a binary. A dichotomous variable is typically recorded, right? But any condition or status that you're interested in, employed, unemployed, for people in the labor force. Of course, there's a third level, people that are not in the labor force. That could be there. People that have a medical condition, like those that have cancer, that versus no cancer, right? It's another categorical variable. So any number of things might be used to describe the population in your study. In any one study, data collection, you might have dozens of different variables on different types. Right? A bunch of them, particularly in surveys, will be of this qualitative type. How do we describe these? Variables. It's at face value, not overly complex. You can do the count by category. How many in your study have different levels? How many women? How many with cancer? How many without cancer? Right? You can convert that to percentages or decimals. Many types, it's easier to compare percentage and decimals than just to think about the raw numbers and judge their size and things like that. Some graphs are used for that. Some bar graphs of showing counts of something or other. There's other kind of segmented ones that kind of do percents. We'll look at a few. There's different graphs. There might be some pie charts. We'll look at a few graphs as we go along. But that was mostly for use for communication, right? But what's I think interesting with categorical variables is in looking at the categories by another variable, or looking at the association between classifications, right? You get more of a story, you learn more about things by looking at associations with another variable. So we're going to look at some examples on the handout. Does everybody have a copy of the handout? Right. Then look at some examples, think about some issues of some measuring some associations, right? And think about communicating about those. So the first example there's data on apartments sold in Minnesota, Minneapolis. This is a small data set that's included in one in a different introductory textbook, actually the one we use for 120, right? And so there's 25 apartments that are sold during a certain period of time. And one thing that's associated with the apartment as a categorical variable is their condition. So the variable is the condition of the apartment, and the responses can be excellent, good, or fair. You could have poor. It turns out in this particular sample of 25 that are sold that there are none that end up being poor. 6 are excellent, 14 are good, and 5 are fair, which is our 25 apartments, right? Now you might think about these are, this might not be a random sample. It might be just the ones that are sold at a certain time. But in some sense, it might be representative of the housing stock that's coming available, right? If the next month is going to be similar to this one, or next year is going to be similar to this year, this would still give you some kind of guidance as to what it's going to be somewhat like, shift and change and so on. But it might not be too different, right? So we can certainly look at the percentage of the houses that are of each condition, right? We can take the fraction, 6 out of 25, right? That's 24 out of 100, or 24%, or 0.24 as a decimal. If I choose to do the 24%, which I probably would, if I had to write a sentence describing, for somebody to read, I'd say that of the 25 apartments sold in this time period, 6 or 24% were in excellent condition, 14 or 56% were in good condition, and then 5 or 20% were in poor condition, fair position, and nothing in being in poor condition that was sold during this time period. Okay? And that would communicate to whoever's interested in this, what's going on. Right? What would be some other variable you might like to know about these apartments? Your real estate.
Location.
What location? Right. So what type of location? What do you want to know about location?
Waterfront.
Waterfront, yeah. So is it waterfront? Or does it have a view?
Golf course.
Is it associated with a golf course? Yeah. So these would be, so yes or no, right? Yes or no. they might be reported as 1-0, or something like that. Those are great examples of categories that we might like to know. Anything else? Yeah.
If it's a city.
City, so the location also, city center, neighborhood. If you look for housing on a neighborhood or information, it might have a dozen different neighborhoods in there. And so that would be, is it in the city center? Is it in a particular neighborhood? I could have many levels. That might be of interest. Does it have a part? Yes.
Like proximity to schools?
So proximity to schools, right. And how would you measure?
Distance.
So distance. So you could actually do, distance. Right, you could do kind of miles, right, of some sort. And then there kind of is the question, are you going to take the location to that and do the closest distance, right? Or do you have to do walking distance, right? Maybe you have to go over here, cross the street, come back. And so distance in an urban environment is kind of interesting to do, right? And so for other things, distance, in a metro city like Washington, DC or Boston, there's how close are you to the metro, right, or the subway, right? Because depending on how far you have to walk to that, you could travel a long distance pretty fast. But so yeah, it can be distance, right? But if you're kind of marketing this or presenting it to people and you're a real estate agent, maybe they don't know how to think about miles so much. Right? They don't know how far is a mile, what would be too much for me, yeah.
Minutes.
You could do minutes walking, right? You can convert that to minutes. Yeah, that might be easier too, right? If you had a cutoff as well, maybe you would say, near, at the other end, maybe far, or, kind of moderate, some word in there, so medium or something. So you might make a cut and say, these are near to the metro. By that, you might mean is within 15-minute walk, right? And then 15 to 30 minutes is the next one at over 30 minutes, right? Could be the category. Maybe that's easier to communicate to people, right? Or if I want to search based on a distance, and I can search for near, right? That might be easier for me to do. So those will all be legitimate ways to do it. You might have all of these together. Right? If you actually record distance, convert it to minutes, and things like that. Distance, depending on how long you have to wait to cross at some big lights, and so on, might be different depending on which side you're walking from. So in an urban environment, it's kind of how do you get that? It's kind of a programming geographic information system, GIS problem about how to measure distances and do all that conversions and things, right? Any number of things, right? And there's a bunch of quantitative variables as well, right? The price, square feet. There's some quantitative ones that will look almost categorical, right? Like number of baths, number of bedrooms, those are going to be counts, number of parking spaces. Those are going to be counts of small numbers. They are quantitative, right? Because you can take 5 rooms plus 3 rooms, and you have 8 rooms, right? So it's number of rooms of different types, number of parking spaces, if that's relevant. But anyway, any number of things. And one possibility is to look at the original, any of these variables, by this excellent, good, fair, poor condition. Are there any differences on any of these other variables within those categories? What makes an excellent apartment, right? Excellent. And so we have a handout. There's the handout. So in terms of this first page of handout, we've looked at most of this. But you might look at things like sales price within the excellent, within the good, fair, and so on. And here's averages and medians. We'll do more with those quantitative summaries later on. But this would suggest that the excellent ones are getting a higher price than the good and fair apartments for some reason, maybe related to some of those other variables. But any questions so far about things that we might do? Part of applied statistics is taking a problem and then thinking of all the different variables that you might record. What's going to be easy to record? What's going to take more work? What are different ways of recording the same concept? What's going to be useful for you to know? And so, yeah, being creative and thinking about it is. Here's a different example, a medical example concerning with hepatitis C. So hepatitis C is an infectious disease, can cause liver damage or even death. Right? It's sexually transmitted, also be transmitted by blood, so syringes and things like that. So this is a study, was originally from a different textbook by Dick DeVoe and Ed Williams, a co-author. And of the 626 individuals in the study, 47 had hepatitis C and 579 did not. Okay? Some, the generation that is in their 60s, 70s, now that were, is being more affected by this. Right? That it's, so it's a growing health problem. So 7.5% of this particular study had hepatitis C, right? And so what's associated with that? Right? Well, one thing they asked in this study, do you have any tattoos? Right? Tattoos involve needles, so they pierce the skin, so infected equipment could spread the hepatitis C virus. So of those people that, the 513 that did not have tattoos, of hepatitis, the 47 that had hepatitis C, 22 had no tattoos, and then 25% did. Right? Of the 579 that did not have hepatitis C, 491 had no tattoos, and 88 did. So there were 513 out of the 626 overall that did not have tattoos. Right? And so you can add up the rows or columns as you wish. Does it appear that these variables are related to one another? Why does it seem like they're related?
Well, there's far less people with tattoos, and they still have the same amount of people getting Hep C, so it seems like the correlation's pretty high there.
Yeah, right. So they had about the same number of Hep C, 22 and 25, but there were so many more people with no tattoos that it's happening at a lower rate, right? So you could focus on that, right? There's more than one way to express this, depending on whether you look at the rows or columns, right? So there's really three ways to take this, I call this a two-way table because it's two variables, and turn them into percentages, right? And so here's three ways that you can turn things into percentages. And depending on what you want to answer, you're going to calculate things differently, depending on the specific question that's being asked, right? So Harrison's question, right, up here, I think was about these rows, right? Of those people that have no tattoos, only 4.3% had hepatitis C. That would have been 22 out of 513. 25 out of 113, though, is closer to 25%, not quite, right? It's 22% of those individuals with tattoos. So if you have a tattoo, the rate of having hepatitis C, that's about 5 times as much. Right? That's a pretty big increase in risk for that. And so these two add up to 100%. Whenever you're given tables and things like this, it's good to try to figure out where it adds up to 100%. Sometimes tables won't add up to 100% exactly by rounding. It might be 101 or 99. Hopefully it's not off by too much. So yeah, you could look at it this way. This is looking at the columns, 100% going down to the columns. Right? So taking the denominator in the column and dividing each of those numbers by that. So taking the 22 out of 47 and 25 out of 47 in that column, right, gave these two numbers. So using the columns, does there look like there's an association? You could answer it that way too, right? Among those with hepatitis C, 53% had tattoos. But of those with no hepatitis, only 15%. So there's a big difference there. That's another way of looking at the association. And depending which way you would want to look at that, depends on exactly how you want to express it. Right? And the homework has some quantitative summaries, and it kind of asks one way, and asks something looking the other way. So you're trying to figure out, is it asking about rows, or is it asking about columns? And it's just in the wording, there's a little difference. Right? This top one just is saying that there's 3.5% overall, all of these numbers, these 4 numbers, or these 2 rows, these 2 columns, add up to 100%. So 3.5% have no tattoos and have hepatitis C. So out of the, where is that? This one? Where do I want to go? Yeah, here. Out of the 626, 22 out of 626 is that 3.5%. So you can say what's the percent in one particular cell, if that's of interest to you. Right. And it's sometimes possible to get more information. Right? One of these stories here about conditioning on information, using more information. If you use more information, you often can enrich the story and learn more. Right? So if the people who have tattoos said, where did they get the tattoo? Did they get it at a tattoo parlor or other? Looking at the raw numbers here, well, you can kind of struggle with it and try and figure out what does that say? What's the difference? The tattoos, tattoo parlors or others, doing it at home or having a friend do it or something, is about the same denominator, 52 or 61, but the tattoo parlors have more hepatitis C. If you convert it to percentages, that at 100% going across the rows, right, then it's a little more clear, right away that there's a bigger risk in those tattoo parlors. So if those were the data from a study, what did you do about it? For instance, if you were in the Department of Public Health and saw data like this, yeah.
I mean, I'd probably recommend people don't get tattoos, and if they did, don't get them at a parlor.
Right. That would be one response, right? That would be the safer thing. But say somebody's going to get tattoos and doesn't want to do it themselves, right? And so if you could have new regulation that says these tattoo parlors have to have a higher standard of hygiene, more screening, more training to make sure that it was done right, maybe that would reduce infections in the future, right? So a couple messages could come out of it. Any questions about it? All right. New examples, right? So one large survey it's done in the U.S. is called the General Social Survey. Asks questions about people's plans and employment and activities and a lot of other things. Used more on the social side of things. And these were individuals who were finishing high school that ended up in the survey. It includes young adults in it. The survey was done in 1980, 1990, and 2000. And these are the responses that were given. People said, what are you going to do after high school? Some people said, go to college. Some people said, get a job, be employed, or military, or travel. And travel might have been a kind of catch-all for other stuff, right? Do you see any pattern? Yes.
A lot more people are going to college now than in 1980.
A lot of people, yeah. So a lot more, right? But this is 288, and that's 320, right? So there's more people saying college.
Right, but there's also less people in general. And they're
There's
all
less, yeah, in this particular group that's responding ended up being smaller. So maybe the budget is smaller and they took a smaller sample, or they just randomly happened to get a smaller number, right? So you can see those things, right? And I think you're right that there's been a change there. But if you change it to percentages, things kind of pop out a little bigger, right? So this is changing to percentages, right? Is that consistent with what you said, that there was 288 is most of that column, right? So the percentage going to college after that, or planning to, is pretty high, whereas 320, even though it was a bigger sample number, they had pretty big numbers over there. And you can kind of judge that, but if you change it to percentages, right, then it kind of takes out some of the guesswork, right? Particularly as a percentage, you can compare these lower numbers, which are kind of hard to just eyeball and see. So I don't know. Percentages, the pattern just kind of jumps out, even though the sample size is a little bit different. Right? Okay. So we're going to look at another example that where the initial story might be different than the story we see at the end. Right? So this is a classic data set, and David Friedman from UC Berkeley Department of Statistics included in his books on statistics back in the 70s. So UC Berkeley admissions in 1973 to graduate schools. Men, there was 8,442 who applied. Women, there were 4,321 who applied. Among the men who applied, 44% were admitted, and among the women, of this number that applied, 35% were admitted, right? So the number of men and women is unequal. This is 1973. In departments of statistics, between men and women, it's about equal. Applications for graduate school and fields like biostatistics, epidemiology, public health, majority of graduate students and applications are from women. So things, this is dated because of the 1973. But was there gender bias in the admission process? Can we assess this based on? So do things, based on this initial summary, do things look equal? No, they don't really look equal, right? Students apply to different departments. And so as it was reported, there were different departments. You might guess that some of these are business or math, physics, psychology, different departments. Right? And these are the number of men that applied to the different departments and the number of women who applied to those departments. This is the percent of men that were admitted. This is the percent of the women that were admitted. Looking at that additional categorical variable in this analysis, does that influence the story? Does that change things a little bit? Yeah.
Well, they seem to be pretty much like around equal except for the A department, because that's like a pretty big jump, 20%.
Yeah, that's a bigger jump, right?
But other than that, it's only off by a couple, which is like fairly the same.
Yeah. So by department, it's more similar. There's a few differences in there. This is kind of the big difference in kind of what's going on here. Yeah, so kind of within departments are similar. So if it was similar before, by department, admission rates are pretty close. How did we end up with women overall getting a lower admission rate?
Well, if you look at the number of women for each department, it's typically less besides in Department C.
So in Department C, women are applying more. D and it's a little bit less, but not too different. Women are applying more to E. It's about a little bit different there. It's very different in these two, A and B. So men and women have kind of a different mix of representation of those different departments. They're choosing different departments for whatever reason. Right? But that's certainly part of the story. Right? And yeah.
There's about like half as many women that applied overall than men, so that percentage is going to be off. Definitely.
Yeah, there are fewer women that apply, right? But even with that, we could have kind of distributed the men and the women to departments kind of equally. We could have said 10% of the men and 10% of the women apply to this department, and 20% apply to this department. We could have made it equal. Right, but it's not equal, right? Women favor some departments and men favor some. And do the departments admit at the same rates? Some departments are much more liberal in terms of admitting, and some are quite a bit restrictive, right? This one is very restrictive. There's some others here in the 20s and 30s. There's a couple A and B, quite a bit, right? So what do we see in this pattern? Why do women end up as an aggregate with a lower admission rate? Yeah, go ahead, Harris. Yeah.
Well, it seems like there's less women applying to A and B, but more of them are getting in. Whereas where there's more women applying towards C, D, and E, less of them are getting in. So the percentages kind of show you that it looks equal. You got to look at the actual number of women that are applying.
Yeah. So there's these couple of things going on. Some departments admit more freely and some are more restrictive. And it happens that women are applying in a higher relative percentage to the ones that are more difficult, and men are applying at a relatively higher percentage to the ones that are a little bit easier. So it looks like the men have a higher rate overall, but it's a little more nuanced than that. Now, there might still be some bias, and I'm not trying to explain all this away. In some of these places that there are differences, right? And so that's not the full answer to the story, but this type of thing happens with these categories. And it's a general phenomenon, and it goes by this name of Simpson's paradox. Simpson was a statistician, probabilist back in the 1950s, who wrote an article just kind of describing this process, right? And the idea is that by conditioning or splitting data by another variable, an apparent relationship that was there originally might go away, or it might be reversed, depending on how things go. And this is not supposed to be a question, that's a typo, you can make that up. Period, that's not really a question, it happens. The variable that you break it on is sometimes called a lurking variable, it might be called a confounding variable, but it's another variable that might impact the relationship between those two, right? And it needs to have a difference between the group, right? So if a lurking variable has the same distribution in the men and the women, the men and women were applying to the departments at equal fractions, this wouldn't happen. And there has to be a difference, right? So in the outcome, that if the admission rates were the same in every department, it wouldn't matter. I mean, we'd have the same, we wouldn't reverse the relationship. So it's a little more subtle, but it happens in a lot of things. And I think beyond this case, it points to the value of looking at relationships by other variables, right? So here's a different take on this, right? But any questions about that? So writing about Simpson's paradox and explaining relationships of these, right? It's not always just one sentence. It might take a little bit of subtlety of looking at things. So imagine that we're going to a hospital for a fairly routine, but a procedure with some risk to it. Appendectomy or something else. Like usually it's not fatal, but every once in a while it goes wrong. We have two hospitals. And Hospital A is 2,100 patients that have this procedure, and Hospital B has 800. And in Hospital A, 63 patients die, so 3% die. In Hospital B, 16 out of the 800 die, which is 2%. Which hospital would you rather go to? Paul, this is yes.
Hospital B.
Yeah, this is what you knew, right? Hospital B has the greater survival rate, 98% survival versus 97. So that looks a little bit better. Right? If you know more information, it might influence, right, your opinions, right? And that's kind of the point of conditioning on another categorical variable. Right? So imagine that the patients aren't all equal. Right? Some people come in, and other than the appendicitis, they're healthy. They're strong. They don't have any other conditions. They're pretty, in good condition going in. Right? Maybe they get it early, get treatment right away, and things look good. These could be the good condition patients. Right? Other patients can come in poor condition. Right? Maybe they're elderly, maybe they're immune compromised, or maybe they have cardiovascular disease and had a heart attack or something. They're not in good condition. Right? Or their particular version of the problem is just worse, right? So if these were the data, right, taking the 2,100 from A, if 600 were here and 15 were here, if Hospital A got more patients in the poor condition, we could imagine just hypothetically that Hospital B would split its 800 patients in these two ways. So the majority of its patients come in the good condition. Right? Now we could have, and data that are consistent with that other table, where 6 out of the 600 or 1% of the Hospital A die, but 8 out of the 600 or 1.3% die in Hospital B of those patients in the good condition. Then in the poor condition, there were 63 deaths here, so 6 here and 57 there. That gives a rate of 3.8%. There were 16 deaths overall in Hospital B, so 8 up here, so 8 more down here. And 8 out of 200 is 4%. Now comparing the percentages, which hospital looks better? Now A looks better. Right? What could be kind of a story you might tell or something that might describe why this would be going on. Right? How would you summarize this a little bit to interpret it? Yeah?
Hospital A could be like in inner city Chicago where there's like more shootings and stuff like that, and like people are coming in with like tough wounds. And then hospital B could be like in a suburb somewhere where there's less like harm going on to the people.
Maybe so, yeah, right. So hospital A, for some reason, is getting this mix of its patients. The percentage of patients that come in a poor condition is higher. But maybe it's a research hospital, and maybe it's big, and it has more resources and more expertise and does a better job, a slightly better job. These percentages are not drastically different, right? But it does a little bit better in this group, and it does a little bit better in that group. It just happens that it gets this patient mix that is a little bit harder to deal with. And that's what they call it. They call it a patient case mix. So U.S. News and World Report or some other things that ranks hospitals, right, they try to take account of the fact that patient populations are different. Right? If you're a place that has an old population, their survival and conditions are a little bit harder. If you're in an area that has a lot of poverty, bad diets, or that has a higher smoking rates or whatever, higher drug use rates, then the hospitals have a tougher patient case mix. And so calling them worse just because they have worse patients to begin with isn't quite fair. So kind of doing an adjustment by this. What they actually do is a little more involved and sophisticated, but at the heart of it, it's adjusting for other variables that they know about, right? So that they can kind of equalize things a little bit better. So if these two hospitals had the same mix of patients, hospital A would be doing better because it has better rates within each type of patient. But any questions? So in describing categorical data, there's thinking about what variables could be categorical, looking at counts and percentages, and then paying attention to, are there other variables that might moderate the relationship that we really can describe. Right? What I wanted to show you are some just different examples that, because most government agencies, health reports, and other things include some description based on categorical variables that are kind of interesting to look at. So, you don't have these. These are included on the website for the class. So if you wanted to download these or look at these again, they're there in the files, right, under lecture 4 today. Right. So one of these is, let's look at this one first. Right. So the National Center for Health Statistics has a weekly report called Mortality and Morbidity and Mortality Weekly Report. So it looks at some aspect of things, of health from some government survey or other reporting. And the topic changes every week. So this was some time past, and here's one report. The percentage of children aged 6 to 17 who wear glasses or contact lenses by sex and age group. This is some data from the National Health Interview Survey in 2016. This is one example, kind of a graph you might make for looking at some of these percentages. Right? The error bars on here, well, there's a percentage. So boys overall, the total here, right, is about 29%. Right? Girls, the percent looks like it's about 35% or something like that. But these are based on a survey. Right? So it's not necessarily exactly the population, but if this was a pretty well done survey, those are pretty representative. And those little error bars represent the standard error or confidence interval. So we probably think for the population it's somewhere, that looks like plus or minus 1 or 2%. It's pretty accurate, right, up there. But those little error bars describe the uncertainty about them. And we'll have formulas, some simplified formulas for eventually calculating those. But so what are the categorical variables that they're using in this graph? What are some of them? Gender. Yes.
Age.
Age.
Yes.
Yes. Yeah. Right. And also the outcome itself, right? Yes or no. Right? So there's really 3 things going on here, right? And it's kind of interesting, right, that it is increasing over time, but for some reason girls end up are looking higher in terms of the higher percentage. Is that because boys? Is there a biological reason that or are girls more willing to say something? Are people paying more attention? Or do they need it more? I don't know. What that kind of, it might be either a biological phenomenon or a social phenomenon, or some mix of those. Yep. You also can get, so the National Center for Health Statistics has this National Health Survey. They also ask about health insurance coverage, right? And so let's see, here's some text. Here's a different graph. Looking at percent of adults aged 8 to 64 who were uninsured or had private or public health coverage at the time of the interview between 1997 and 2000. Right, so private, right, and then this lighter one is uninsured, and then public, right, is this, right? So what do you think is going on in this graph? Yeah.
More people prefer private insurance or public insurance.
Yeah, more people in private's more common, or public. You add those together, right? It must be 88% or so. The Affordable Care Act came in during this period of time, right? So maybe the public insurance was bumped up under the Obama administration and after, and then the uninsured dropped. So you see those things going on, right? What are some of the categorical variables? Yes?
Age.
Age, right? We could have age. This is everybody's together, 18 to 64. But it would be meaningful to split it into different age groups. I think that would be interesting, right? But public, uninsured, and private, these three levels, that's a categorical one, right? Year, you can average years in some way, but that's almost serving as another, a different response variable. You might use it kind of as a quantitative one, but it's you get the survey every year, right? So anyway, percentage of adults uninsured at the interview, and here's age explicitly as a variable, right? So it looks like the 25 to 34 and 18 is the highest, and the 45 to 64 is lower, right? 65 plus is a different category. They might be eligible for Medicaid or Medicare, right, for elderly health insurance. Right. So anyway, yeah, so different type of graphic doing that. One project, this should not say DPP, it's a different study, but one study that I've been involved in that's kind of ongoing is to look at the impact of treatment with antibiotics of a condition called bacterial vaginosis. So it affects women in pregnancy and is associated with preterm birth. Right? And so there's been a number of studies around the world, a dozen or more, that have looked at, is there any benefit to treating women who are asymptomatic, that they have to be, it's not obvious that they have it, but once they're tested, then they have this infection, and does it reduce the chance of preterm birth, right? Among other things, right? And so one thing in the study is once you bring all these different studies together from around the world, these randomized clinical trials, and get their data, you can look to see, are the treatment and control groups relatively balanced? Did the randomization work well in these different things? And these are some of the variables that were in the studies, right? The percent of the women that had twin pregnancies in the different studies, right? This is obstetric history, the previous preterm risk. Nulliparous is with the first pregnancy. These are women who've had at least one pregnancy before. Some of the women have not had a previous preterm birth, others have, and some of that information was missing as well. And they're pretty close. The numbers out here, these p-values, were the measure of how different they were. So there was a little bit of difference here. But there was some clustering by study. In any case, eventually we'll have some significance tests and we'll learn more about what those numbers are that are out there. Smoking status, race, we were limited because we had to take these studies, some of them done in different countries, some done in homogeneous populations. A few studies had more race ethnic divisions, but in terms of aggregating them into any large level across the studies, those were the ones. But it's mostly balanced. And then, of course, there were many different quantitative variables affecting, pregnancy that were there. We wanted to look some at smoking was there. Not enough studies reported on alcohol or drug use. So, yeah, maybe 2 or 3 out of the 12 do it, but there wasn't much point in providing that extra table. These are the ones where it was not, this was missing or unknown for a third of the women in these different studies, but it still seemed worthwhile reporting that. So those are some categorical variables that communicate something about the study populations. One last one as an example, the USDA, produces, we'll start back at the beginning here, reports. There's a census of agriculture that goes on every 5 years where they actually try to gather information from every farm in the United States, right? So it's millions, right? What they're growing, what chemicals are they using, how many people are employed, financial structure, all of that stuff, right? So, this particular presentation has a lot of nice colorful graphs and things like this. Right, so here are the states, the change in the number of farms. Is this picture showing us primarily a quantitative variable or a categorical one? Yeah.
I'd say a bit of both, because while it's putting it kind of into like color categories, it kind of like make it easier to explain. There are like still like numbers that are describing each category. So
yeah, it's kind of one of these intermediate ones, right? So underlying it is the number of farms, and that's definitely quantitative, right? You can use the numerical change, makes sense, between the number of farms. And then it's converted it to a percentage and put cutoffs. So it's kind of taking quantitative information and made it easier to look at, sort of, by putting it into a category, right? So a little bit of both. There's New England, land area, and farms and acres. What's the mix of variables in this one? Well, acres certainly is quantitative, right? So the number of acres. The number of acres is, but they do report it by categories. Right? So these qualitative things are categories, but it's a numerical value. Right? The average, you can take the price per acre and multiply it by that and get a total dollar value that would make sense. So it's a quantitative outcome, but split by categorical things. Percent of New England farms by New England National North American Industrial Classification System, something like that, right? And the percent. So this is a categorical or qualitative variable with a lot of different categories. Right? And it looks like, what's the purple one? Animal aquaculture and other animal production. Right? Seems to have gone bigger there. Oilseed and grain farming seems to be shrinking down there, almost out of existence. But in any case, it gives the kind of total percentages. Right there. Right? Cash receipts, these are dollar values, right? Price of milk, and amount of milk, and so on is there. A few of these others are kind of the same thing. They're quantitative ones split. If we go down here far enough by percent of farms with direct sales. So this one, right, this is all categorical variables, all qualitative, right? What variables are in this picture? Yeah.
Separated by state.
State, right, is one. Yeah.
Percentage.
So the percentage, so the ultimate question, yes or no, are you involved in direct sales or not, right? Yes or no is one. And then stage, direct sales, and then year. There's 2002, 2007, so there's 2 different survey years in there. And they probably have done, I don't know if I haven't found, you know, if you search long enough, you might find it for 2012, even 2017 to compare. So there's a few other things in here. There's some of these others, percentage of farms with organic sales. Again, by state, yes, no, by year. But look at that increase in percent of farms with organic sales. Here is Vermont is at the leading of these New England states, but still it's only not much, kind of interesting to know it's gone up from there. Percentage of farms with women principal owners. So a lot of interesting stuff comes out in these variables, I think, right? And so on. Those are just some examples of how it's used in meaningful ways. On Wednesday, we'll come back and look at quantitative summary of mean standard deviation.
Probably around there. Read over this way. Read over, go.
Oh, yeah.
Thank you.
It's not too bad, I guess, so far.
Thanks.
Have a good day.
Have a good day. Oh, that's fine. Yeah, you, yeah.
Thank you.
Okay,